So the binomial theorem has something to do with binomials. In other words, a plus b to the nth power. Of course, it can be negative. I gave this example with 10 students choose 4. 10 choose 4. We also can calculate it with a calculator directly. 10 choose 4 means 10 factorial divided by 10 minus 4 factorial times 4 factorial. The definition is right here. N choose k, n factorial over n minus k factorial times k factorial. And we calculate it and we get to 210. Okay. Why do I need this? Why do I need this? Okay, here's the reason why. When we want to raise a plus b to the nth power, we have to use these coefficients. From n choose 0, I shouldn't put plus here in a moment, dot, 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 till the last one, n choose n. N choose 0, n choose 1, n choose 2, n choose 3, and so on and so forth. N choose n minus 1 till n choose n. These are the coefficients that will pop up in front of each term. The first term will only have a to the nth power, but the second term will have a to a power lower than n by 1, and b will pop up, times a to n minus 2 times b squared. Next one, plus a to n minus 3 times b to the third, plus dot, 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 till a has disappeared and there's only b to the nth power. These coefficients have to be determined with the formula n choose k. So this is very abstract, kind of difficult to comprehend. Let's look at a very simple example. Let's say 2x plus y squared to the third. Okay, so I have 3 choose 0, 2x to the third power and no y, plus 3 choose 1, 2x decreases its power to 2, and then y squared pops up to power 1, plus 3 choose 2, 2x decreased from 3 to 2 and now to power 1, y squared nothing, y squared to the first power, so now it's turned to y squared squared, plus last one, 3 choose 3, there is no more 2x, power 3, power 2, power 1, power 0, which means 1, and now y squared is raised to the third power. This is what this means. For a simple example, 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. There is nothing else. Always these are 1. Don't ever need to calculate those. The first one is only 1. 3 choose 0 is only one option. 3 choose 3, there is only one option. These have to be determined. So let's determine 3 choose 1. And we finalize the binomial theorem on a simple example. So 2x plus y squared to the third. I already have 2 to the third, which is 8, and x cubed. I have completed term 1, plus 3 choose 1. Okay, so 3 choose 1 is 3 factorial over 3 minus 1 factorial times 1 factorial. Well, this is 3. So I have a 3 from this, I have to raise 2x to the second power. I have 4x squared times y squared plus. This is also 3 choose 2 will also be 3. So plus 3 times 2x times y squared squared, which is y to the 4th, plus y squared to the 3rd, which is y to the 6th power. Final, 8x cubed plus 12x squared y squared plus 6 x y to the 4th plus y to the 6th. And you can say, but wait a minute, why don't you just multiply it 3 times? You're going to find me here tomorrow night, I'm exaggerating, by the time I finish all this. And this was just one line, and just determining some coefficients and then multiplying. For me to multiply this 3 times, it will take much longer. And if I put here 8, it will take me a day. I'm exaggerating, but it will take me a long time. And with the binomial theorem, I only have 2 lines to write. And finally, I just wanted to mention that these coefficients can be determined with Pascal's triangle. 1, 1, 1, 1, sum, 2, 1. And we know this. A squared plus 2ab plus b squared. 1, 3, 3, 1. And that's exactly what we had. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. And we can continue forever. This is when n equals 2. A squared plus 2ab plus b squared. This is when n is 1. This when n is 0. Of course, this row is when n is 3. Of course, n is 4, n is 5. So when n is 3, we got 4 terms. 1, 2, 3, 4. 1, 2, 3, 4 terms. When n is 4, 5 terms. When it's 5, 6 terms. Always one more. So remember from the beginning of the class, a plus b squared, 3 terms. Now a plus b to the 3rd, 4 terms. So you can use n choose k, and I'll stop. This is the end of the new material. There is nothing else. I just wanted to show you where to find this in the calculator. It's still in math. It's still in probabilities. And this is it. N choose k. It's R. So we have to enter 10, choose 3. So what I had was 10 choose. What was my silly example with the students? 10 choose, what was it? 10 choose 4. Okay. And we obtained, when we calculated it, what was it? 210.